This is 5.4. We're going to be graphing more trig functions, and we've already graphed sine and cosine. If you haven't watched 5.3 yet, go back and watch 5.3, how to graph sine and cosine functions. Now this is basically all the other trig functions. So once you know sine and cosine, everything, as I've mentioned before, all the other trig functions are based off of sine and cosine. So as mentioned before, sine and cosine have period 2 pi. So again, I've said that to you guys before, sine and cosine have period 2 pi, which obviously means that cosecant and secant, the reciprocals of those, also have period 2 pi. Now, if you look at tangent, now let's start looking at tangent. So we know sine, cosine, secant, and cosecant. But let's look at tangent and cotangent. Now tangent, if you look at like the 4 major points that we're looking at here, so 0 pi, pi over 2, pi, and 3 pi over 2. If you look at those major points, so tangent of 0 pi, tangent is sine over cosine, and so sine of 0 pi, cosine of 0 pi, and notice you're going to get 0 over 1, which is 0. And that's the same thing as if you go pi units. So 0 pi or pi, you're going to get 0 for that. So, and then at tangent pi over 2, if you try tangent pi over 2, you're going to end up getting undefined. So look at the graph. So when you start graphing this, you notice like at 0, it's going to be at 0. And at pi over 2, it's going to be undefined. So you have a vertical asymptote. So if you go anywhere in between, like if you went a 30-degree angle, pi over 6 or, pi over 4, if you start graphing that, the graph you'll start seeing it's going to look like that. So a tangent function sort of looks like a cubic function. Okay? It's not a cubic function, but it looks like a cubic function. So, and then the vertical asymptotes, again, it's only pi units away. The period's only pi units. In between pi over 2 and negative pi over 2. And then it starts, it literally repeats itself again. The next period looks like that. The next period looks like this. So it just keeps repeating itself like that. But every period of pi, it repeats itself, but it counts by pi over 0 and then pi over 2. That's 1 over pi, then this would be pi, and then 3 pi over 2. All right, and that's what tangent looks like. And then cotangent is literally going to be like, the flip of that. The cotangent will look like that. Okay? Except, let's look at all the graphs. Okay, so tangent and cotangent, I just now described those. And again, if you look at your unit circle, okay, 0, and then it just follows that pattern on there, and you can literally graph it that way. And again, keep in mind that it's undefined at pi over 2 and negative pi over 2, because you can't have 0 on the bottom. Now, as far as cosecant and secant, now, let me explain this. So cosecant, the graph of sine, so cosecant is 1 over sine, okay? 1 over sine. And remember, you can't have 0 on the denominator, so if you look at the unit circle, where is sine 0, and you can literally see at 0 degrees, so sine of 0 degrees is 0. And so that's going to be literally undefined right there. So you have a vertical asymptote right there. And the same thing at pi. So again, think of the unit circle. So here and there, it's going to be, that's the point 1, 0, and that's the point negative 1, 0. And you can't have 0 on the bottom of a fraction, so that's why you have a vertical asymptote every pi unit starting at 0. Okay. And then if you graph the sine function, this is how you can easily memorize this. If you graph the sine function, it literally looks like this. And so the cosecant, the reciprocal of it, basically looks like parabolas on the high and the low points of the sine function. And the same thing with the secant function. If you look at the secant function, think of where cosine, if you graph cosine, so again, the blue is cosine. Graph it, remember it starts at 1, and then it goes down to here, and then it goes down and up, and then it goes back up. And again, it's at the highs and the low of the cosine function. And again, the whole reason is because the secant function, remember the secant function is 1 over cosine, and you can't have on the bottom of a fraction, and which means like at 0, 1, it's undefined. That's cosine, and so you can't. At pi over 2, you have a vertical asymptote because it's undefined right here. It's 0 right. Cosine is 0 right there, and you can't have cosine of pi over 2 is 0, and you can't have 1 over 0. So that's why you have a vertical asymptote. So you have to notice where your vertical asymptotes are, and then you can easily graph those other functions. All right, so let's look at a graph like this. Now, what I have graphed is, this is cosecant, and remember the sine function is what's graphed there. Okay, remember the sine function starts at 0, and then it goes up and like that, okay, like a wave. And then also notice the amplitude is 2. That's the amplitude. So I automatically went up to 2 and then -2, down to -2. So if that's the sine function, let's actually graph cosecant function. Oh, by the way, the period. Remember, the period is always for sine functions and cosecant functions. It's 2 pi, and you're going to divide it by k. This is your k. So 2 pi divided by 1/2 is 4 pi. So it repeats itself from here to there. That's 4 pi, which means half of that is 2 pi, and then half of that would be pi. So it's counting by 1 pi. So 1 pi, 2 pi, 3 pi. Okay, and that's one complete period from here to there. Okay, and remember, at the highs and the lows is where the actual cosecant function is. So if we graph the cosecant function, we're going to graph that in blue. See, there's a vertical asymptote here, like a parabola. Again, at the highs and the lows. So it keeps going like that. And one period, by the way, remember, a period is where it starts repeating itself. So, so from literally from here to there is one complete period. Okay, so from 0 to 4 pi is one period where it starts repeating itself. All right, and that's cosecant function. And by the way, let me make sure you understand. The red function is the sine function, and it only helped me graph the blue. The blue function is actually the graph that is my final answer. Okay, the blue, that is cosecant right there. Okay, 2 cosecant of 1/2 x, that's graphed right there. The red was there just to help me guide my cosecant function. See, I just graphed the sine function first, and then that helped me guide my graph for cosecant. And then let me go over this function right here. So there's 2 ways I want to tackle this. So again, here's the function I want to tackle. So if I had something like that. Well, notice a couple things. I did it, one, by an XY chart. So if transformations confuse you, you can always do it by an XY chart. So literally put in 0 and do the math. Put in pi over 2, do the math. Put in pi and do the math. And then you can start graphing those points, and even literally just doing 2 or 3 points, then you can fill out the pattern and do that. All right. So again, it still has period 2 pi. Cosine has period 2 pi. But notice, as far as transformations, so we're the cosine function normally. Let me show you normally. Let's do that in blue. The cosine function normally starts at 1, and then it starts going down. Okay, and then down like this. Okay, so that's really what it normally looks like. Okay, so 2 things. One, it's being scooted up 2 points, and the amplitude is 2. So notice what's actually taking place there, and so it's going all the way as high as 4, and it's being bumped over pi units to the left. So notice it's going up to here, but it's being pi units to the left. Okay, that's that. It's being scooted over. And then the negative flips it down to here. So this is actually your starting spot. if you're actually starting, so if you're doing transformations, that's actually your starting spot right there. Okay, so again, we went up to here because we scooted up, it's amplitude 2, and then we got bumped up 2. Okay, it's amplitude 2 because of that, and then it got bumped up 2, okay, and then it got shifted to the left, and then it got flipped. Okay, so that's actually your starting spot. Or again, once you can do this, you just start an XY chart and do it from there. So hopefully you understand how to graph any of the trig functions. I showed you transformation-wise, and I showed you using the XY chart. Both methods, you can use either one that will help you.